Hello.
Good afternoon. How are y'all today?
Good.
Good. Yeah.
We've got a couple more people that have been trying to join. We'll see if they're able to have the meeting recording. We'll get started on reviewing for exam 2 here in just a couple minutes. Okay, can y'all all hear me okay?
Yes, sir.
Excellent. Well, what we are going to do both for today and Thursday is review for our second exam, which is due. Let me pull up that date so I can see it. I'll tell you true things and not untrue things. Almost there. Okay, exam 2 will be due on the 27th. That is Friday. And I'll have that up and ready for you to go on Wednesday. Again, we'll have a second session where we review for this exam on Thursday. So you may want to wait until Thursday evening or Friday to do exam 2. That way we will have had a chance, to go over as much of the material as possible. Any questions before we get started working examples? Okay, if there are none, then I will pull up my notes and we'll get started. Okay, so in this first question, we want to graph these two equations separately, of course, using the intercepts. So in number one, we have 6x plus 3y is equal to 12. How do we find the intercepts of this equation? Well, the x-intercept is when y is equal to 0. So in that equation, we can plug in y equals 0, and we have 6x plus 3 times 0 is equal to 12. Well, that 3 times 0 just drops out because 3 times 0 is 0, and we have 6x is equal to 12. And then we can divide both sides by 6. So x is equal to 2. So our x-intercept is the point 2, 0. And we can graph that on the line or on the axes here. 2, 0 is right there. And then we need to find the y-intercept. Well, the y-intercept is when the x value is equal to 0. So we can plug that in and we get 6 times 0 plus 3y is equal to 12. That means 3y is equal to 12. Divide both sides by 3. 12 divided by 3 is 4, so y equals 4. Okay, so that means that our y-intercept is the point 0, 4. We can graph that on the axes. That's 0, 4. And then all we have to do to finish graphing, I'm using my ruler here, is use a straight edge to go through both points. Take the ruler off and be sure to put arrows at both ends. And that's how you would graph 6x plus 3y is equal to 12. Questions about that one?
No, sir.
Okay, let's do number 2. Same story, different verse. We want to find the x and y intercepts to graph this equation. So for the x-intercept, remember that y is equal to 0. So in the equation, we do negative 2x minus 5 times 0 is equal to negative 10. The 5 times 0 drops out, and we get negative 2x is equal to negative 10. Divide both sides by negative 2, and we get x is equal to 5. So our x-intercept is the point 5, comma 0. And we would graph that right here. 5, 0. What about the y-intercept? Well, same sort of procedure. In this case, x is equal to 0. And so we have negative 2 times 0 minus 5y is equal to negative 10. So negative 5y is equal to negative 10. Divide both sides by negative 5. Negative 10 divided by negative 5 is 2. So y is equal to 2. And our y-intercept is the point 0, comma 2. Okay. And so what we can do there is we can plot that point. That's 0, 2. Bring up my ruler one more time, and we'll line it up to get a straight edge through those points and put arrows in both directions. Questions about that one?
No, sir.
No, sir.
Very good. I will post the solutions to these on Blackboard in our co-requisite and in the main course in all likelihood. That way you'll have those. I'll post what we do today in the co-rec, and then I'll post it in the main course when we finish on Thursday. Okay, next example. This time we're just asked to graph the equations. So on number 3, we have y is equal to negative 1/3 x plus 1. So since this is in slope-intercept form, let's see, there's our slope and there's our intercept. We can use the slope, m, which is equal to what value? Negative 1/3. Well, that's our rise over run. So if we can find one point that we can graph, we can use the rise and run to be able to graph another point and then draw the line. So our B, our y-intercept, is 1. That's our y-intercept. So the point 0, 1 right there is on our graph. And we want to find another point. Well, for every 1 I go down in y, I have to go over 3. So the point 3, 0 would be on our graph. So we can graph that. And then again, we get our ruler out. Let's see. And it may not be perfect, but it's pretty close. Questions about that one?
No, sir.
Okay, 3x minus 2y equals 8. What do you want to do first? How do we want to graph this line? Well, the first thing I want to do is I want to solve for y. Change colors here. Solve for y. So I can subtract 3x from both sides to get negative 2y is equal to negative 3x plus 8. Then I can divide both sides by negative 2. And so what I get is y is equal to 3 over 2x minus 4. Because we have negative 3 over negative 2, which is just positive 3 over 2. And we have 8 over negative 2, which is negative 4. So my slope, m, is equal to 3/2, which is the rise over the run. And then my y-intercept, b, is equal to negative 4. So the point 0, negative 4 is on the graph. And for every 3 I go up in 1, 2, 3 in the y direction, I have to go over 2. So the point 2, negative 1 is on my graph. Bring up my handy dandy ruler. Get it to go through both points. Oops, that's my highlighter. There we go. And that's how you would graph that line. Are we good to move on from there?
Yes, sir.
Okay. So our next questions are to write the equation of the lines in slope-intercept form. So remember, slope-intercept is y equals mx plus b, and we've been given a point and the slope. If we're given a point and the slope, what form of the line do we have to start with?
Can't you enter y?
So we can plug in the x and the y into the point slope formula. Oops, point slope formula. And the point slope formula is y minus y1 is equal to m times x minus x1. So y minus our y value, which is -3, is equal to m, our slope, -4/3, x minus x1, which is 7. Now we're almost there. We're not quite there, though. I'm going to make this all a little bit smaller, so we'll have some space. Okay. So y minus a -3 is the same as y plus 3 equals, we can distribute -4/3 x plus what value? 28/3. 7 times 4 is 28. Then we subtract 3 from both sides. And 28/3 minus 3/1. We still get y equals -4/3 x plus 28/3 minus 9/3. 9/3 is the same thing as 3. So 28 minus 9 is 19. So our final, I won't have an equals there. Let's see. An arrow. That means our final equation is y is equal to -4/3 x plus 19/3. So that's sort of the easier of these two problems. I'll shrink this down. So it fits. What about number 6? How do we get started with it? We're actually given 2 points in this one as opposed to a point and the slope. So what do we do? Anybody?
I would do the x the y, is it y2 minus y1 and then the x2 minus x1 for the slope to find that.
Very good. We're going to find the slope first, and then we'll have 2 points actually. We'll have 2 points and a slope, so we can use one of those points and the slope to find the equation of our line. So very good. Hide that up in the corner. So our slope m is equal to -4 minus -2 over 4 minus a -8. So -4 minus a -2 is -4 plus 2, so -2. And 4 minus a -8 is what? 12. So this is equal to -1/6.
Yes.
Again, make those calculations small enough that we can see them, but got to have some space to do the work. So now we have a slope of -1/6 and a point. I'm going to choose to use the first point here in my point slope formula. So y minus a -2 is equal to m (1/6) times x minus our x value, which is -8. So y plus 2 is equal to -1/6 x plus, no, not plus, minus, because we have negative times a positive, -1/6 times a positive 8. And what does that give us? 8/6 minus 8/6. So we subtract 2 from both sides and we get, I'll drop down just a little, y is equal to -1/6 minus 8/6 plus, not plus, minus, we have a -2, 12/6. So that's y equals -1/6, and that should have an x there. X minus 8 minus 12. -8 minus 12 is -20/6. Are we finished there? Can anything be reduced?
Can you simplify 20/6?
We can. What can we simplify that to?
6? No.
Looks like we have a common factor of 2. So we can divide the 20. Yeah, go ahead.
10/3?
10/3. So y is equal to -1/6x minus 10/3. And that would be your final answer.
I think I'm getting confused on like whenever you subtracted 2 from each side and then you got 12 minus 12/6. Can you go over that part again? I'm confused.
Absolutely. So what I'm trying, well, this -2 and 12/6 are the same. So I have a 6 in the denominator already, the 8/6. And so I need something that's equal to 2 that has a denominator of 6. So what I do is I take -2/1, which I think you'll agree is -2, and I need to multiply it by something that gives me a 6 in the denominator. The only way I can do that and it still be true is to multiply by the same thing in the numerator, because 6 divided by 6 is just 1. So with that fraction, I'm multiplying -2 times 6 and 1 times 6. So -2 times 6 is -12, and 1 times 6
Gotcha.
is 6.
Okay, that makes a lot more sense. I was confused in the
that's a-
first one too, but I was just waiting on it.
No, that's a very good question, and one that I'm sure there were others that were wondering, how did you get 12/6? That's a very good question. Thanks for asking that, Kelsey.
You're welcome. Thanks for explaining.
Okay. See if I can make all of this work small enough that it'll fit. There we go. And then I can do the same thing here. Okay. Change colors. Determine whether the following equations are parallel, perpendicular, or neither. So how do we start on this? Well, the first thing I want to do is I see these equations that look kind of nasty. I want to get those in y equals mx plus b form first. So for the first equation, I can add x to both sides, and I get 2x minus 10 is equal to 5y. I can divide both sides by 5, and I get those 5's canceling. So y is equal to 2 over 5x minus 10 over 5. 10 over 5 is minus 2. So that's our first equation. In the second equation, we can subtract 5 from both sides, and we get, I'll move over here, negative 4x minus 5 is equal to negative 10y. Divide both sides by negative 10, and I get those negative 10's canceling, and y is equal to negative 4 over negative 10, or 2 over 5x minus 5 over negative 10, or minus 1 over 2. Do you have any questions about how I arrived at these two equations? Now that I have these in y equals mx plus b form, are they parallel, perpendicular, or neither?
Would they be parallel since they have the same slope?
They are parallel because this slope and this slope are equal. These are parallel. Very good. Okay, time to put this question in the shrink ray. Okay, some of those don't make sense anymore. But minus x and minus x. What about the second set? How do we figure that one out? Well, we have to do the exact same thing we just did. So in the first equation, 5x minus 2y is equal to 4x plus 8. We subtract 5x from both sides, and we get negative 2y is equal to 4 minus 5, or minus x plus 8. Divide both sides by negative 2, and we get y is equal to not negative, 1 over 2x, because we have negative 1 divided by negative 2, plus 8 over negative 2, or minus 4. So that's our first equation. What about the second? Well, we have negative y minus x is equal to x plus 5. We can add x to both sides, and we get negative y is equal to 2x plus 5. To get y by itself, we divide by negative 1 on both sides, and we get y is equal to negative 2x minus 5. And those are our two equations. So are these parallel, perpendicular, or neither?
Well, they're not parallel.
They're definitely not parallel because they have different slopes.
I'm going to guess neither.
Okay. Any other votes? So how do we tell if a line is perpendicular to another line? Well, we multiply their slopes together to see if they equal -1. So if I take 1/2 and I multiply it by -2 over 1, which is -2, what do I get? Well, I get 1 times -2, which is -2, and I get 2 times 1, which is 2. Well, -2 over 2 is -1. So these are perpendicular, excuse me. These are perpendicular. And
did
another
you
way
do-
you can tell.
Did you do it
Go
-2
ahead.
over 1 because the first M1 was a fraction?
I did. It just makes it easier for me to see it. You could multiply that out without having it over 1. Anything divided by 1 is itself. Now,
Yeah.
one thing that you can notice about these slopes is 1/2. If you were to flip that fraction, it would be 2 over 1. If you put a negative sign on it, you have -2 over 1. So if you're able to flip the slope and put a negative on it, or positive in whichever case you're in, if you flip it and change the sign and you get the slope of the other line, they're perpendicular.
And can we always use that formula M1 times M2 to determine that?
You can. So another way that this gets used, when I say negative reciprocal, meaning you flip it and put a negative on it, the way that sort of comes up is if you have M1 times M2 is equal to -1, and you divide both sides by M2, you get the cancellation there, and one slope is equal to the negative reciprocal of the other. So you just flip it.
Thank you
So
much
that
for-
will, yeah, you're welcome. That will happen every single time if they're perpendicular. Okay, that's a lot of work for one problem, especially since there's not room on this. Oh, nope, don't want that. Let's try that again. That's probably not going to fit. We'll just put it up there and say that that's 4 for that one. What about number 9? Find the equation of the line that passes through the point 4, -2, and is parallel to the line 3x minus y is equal to 6. Well, again, first thing I want to do is I want to get the equation that we do have in slope-intercept form. And I think the easiest way to do that in this case is to add y to both sides. And I get 3x is equal to 6 plus y. And then subtract 6 from both sides to get y is equal to 3x minus 6. So for this line we're looking for to be parallel to the line we're given, what does the slope have to be?
Three.
Has to be 3. So the only way we get a line parallel to the line 3x minus 6 is if our slope is 3. So now we have, just like in the previous examples, on number 5 and number 6, we have the slope and we have a point on the line. So we can use the point and slope formula. So y minus y1, which is -2, is equal to m, which is 3, x minus x1, which is 4. So we have y plus 2 is equal to 3x minus 12. Subtract 2 from both sides, and you get y is equal to 3x minus 14. And that would be your final answer. How are we feeling? We ready for number 10? These sorts of line, parallel, perpendicular stuff, they take a lot of time to do, but we'll get to some that are a little bit simpler. Number 10, we want to find the equation of the line which passes through -5, -7, and is perpendicular to 4y minus x equals -12. So how do I start to find the line that's perpendicular? What would you do first?
Do the same to that that you did on 9. Put it in that slope formula.
Exactly. We want to put it in slope-intercept form. So we can add x to both sides to get 4y is equal to x minus 12. And then divide both sides by 4. The 4's cancel on the left, and we get y is equal to 1 over 4x minus 3. -12 over 4 is 3. So we found our slope. What is our slope of this line?
1/4.
Is 1/4. So what does the slope of our second line have to be?
1/4.
Well, remember, we're looking for the line that's perpendicular.
Whatever it is, it has to multiply. It has to go through the equation that m1 times m2 equals -1.
So whatever we multiply by 1/4, we end up with -1. So what we want to do is we want to flip this 1/4. So the 4 goes to the top and the 1 goes to the bottom. So that's the first thing we do. So we get 4 over 1. And because this first one is positive, the only way we get a negative number when we multiply those two together is for it to be negative. -4 over 1, or just -4. So it's the negative reciprocal. So we know the slope of our new line is -4. We also know that it goes through the point -5, -7. Let's move this work over here. So again, point slope. We plug in our point. So y minus a -7 is equal to the slope, which is -4, times x minus our x value, which is -5. So we get y plus 7 is equal to -4x. -4 times a positive 5 is -20. Subtract 7 from both sides, and we get y is equal to -4x minus 27. Did I do that math right? Questions about that one? Okay. What about number 11? Number 11, we want to evaluate the function. Oops, sorry. 6x squared minus 8x plus 1 at various values. So if we evaluate f of -2, we're taking this function value, -2, and putting it everywhere we see an x. So we get 6 times -2 squared minus 8 times -2 plus 1. Well, we have to start using order of operations. we start with the exponent. So negative 2 squared is 4. So we have 6 times 4. Negative 8 times negative 2 is plus 16. Plus 1. Well, 6 times 4 is 24, plus 16 plus 1. 24 plus 16 is 40, plus 1 is equal to 41. So that's your final answer there. F of negative 2 is equal to 41. What if we plug in 5? Same story. 6 times 5 quantity squared minus 8 times 5 plus 1. 5 squared is 25, so 6 times 25 minus 40 plus 1. 6 times 25, I need some help there on that one. 150. 150 minus 40 plus 1. 150 minus 40 is 110 plus 1, or 111. What about f of m? I think I actually prefer to plug in variables into functions rather than just values, because f of m, all I have to do is plug in m everywhere I see an x, and so there's only one step. What about f of 3m? Well, we just plug in 3m everywhere we see x. So we have 6 times 3m squared minus 8 times 3m plus 1. Now, you may be tempted in this next step to say, well, 3m squared is just 3 times m squared. But you will have missed that we need to take the square to both pieces. So we get 6 times 3 squared, which is 9, times m squared, minus 8 times 3 is 24m plus 1. And 9 times 6 is 54 times m squared minus 24m plus 1. Any questions about those? I think that I want us to stop there and come back and do difference quotients on Thursday. I don't think we'll really have enough time to go through all of it. Well, we won't have time to do 13, but let's try 12. So this is what a difference quotient is. It's f of x plus h minus f of x all divided by h. So what we do is we take x plus h in the function. So, oops. So that's equal to 3 times x plus h minus 7. That's the first part. Minus f of x, which is just 3x minus 7, all over h. Okay? So we can distribute, and we get in the first bracket 3x plus 3h minus 7. Probably didn't write that far enough down. Minus a 3x plus, 3x plus 7, because we distribute that negative, all over h. So what we're left with is 3x plus 3h minus 7 minus 3x plus 7 all over h. And what I end up getting when I combine like terms, I have a 3x minus a 3x, and those cancel. I have a negative 7 plus a 7, and those cancel. And all I have left is 3h over h. Well, what's 3h over h? The h's cancel, and I'm left with just 3. So the difference quotient in that first one is just 3. Now, when we come back and do number 13 on Thursday, because we have that square and the other x in the formula, the difference quotient will be significantly more challenging because there are more steps and more things to multiply. But if you want to work on that over the next couple days, and we'll discuss it on Thursday. We're right at 3:50. I appreciate all of you joining today. I will post this video here within the next hour or so once it comes through and finishes recording and all the compressing and stuff that it does. And I'll look forward to seeing you on Thursday, same time.
Thank you.
Y'all have a good day.
Thank you. You too.